Hello, this is Mr. Jacobson again, and we are working on assignment 5.3 to 5.4, and I've had a request to solve number 6. So first of all, we need to know what a pile driver is, and that may have been a hang up for solving this problem, but um, say you're building a larger building or you're building on some ground that's not that stable, like when they built the high school in the swamp. What they do to give that building stability is they drive these large poles, and they can be made of wood. Sometimes they look just like a telephone pole, and they drive it down into the ground, and then they pour their cement footings around the piles, and then that gives the building a lot of stability. Sometimes they're large steel beams that they drive in. It doesn't matter what it is, and it depends upon the situation, how big the building is, and how unstable the ground is as to how big these piles have to be. And then to drive them into the ground, they have this machine that's called a pile driver. And what it does is it lifts this weight up, and then it releases the weight, and the weight goes into a free fall and falls down on the top of the pile and drives it into the ground. So that's what a pile driver is. Now, in our problem, the mass that is being dropped is 1,800 kilograms, and the distance it's falling before it hits the pile is 4.6 meters, and then it's going to drive the pile another 0.142 meters into the ground. So the total distance it's going to fall is 4.742 meters. And so we're going to call this spot where it finally ends, we're going to call that our zero spot. So when we're calculating the potential energy, the total distance it's falling is 4.6 plus 0.142. Now, when the pile driver is at the top, it has gravitational potential energy and no other type of energy. And so all of that energy is going to be converted to kinetic energy right here at point B. And then that energy is going to drive the pile down 0.142 meters. Now we could take and solve this in another light, and we could consider the energy it has right here, and that energy we could either we could call it 1/2 mv squared, but then to calculate v, we would use the potential energy at the top. And then it would have that kinetic energy at that point B, but it would also have a little bit of gravitational potential energy left because it's going to fall another 0.142 meters. So rather than introducing the kinetic energy at point B and adding another layer of problems to solve, I'm just going to start with, I'm going to say that the potential energy we start with is going to be equal to the work that we have. And so that's what I've written right here. So the mechanical energy at A will be equal to the work done from point B to C. And the mechanical energy at A is only potential energy, so it's just mgh. And then the work is force times delta y. And again, I already said this h is the entire height that's going to fall, so it's 4.742 meters, not the 4.6. And so then rearranging this equation for force, we get force equals mgh divided by delta y. So we just plug our numbers in, 1,800 times 9.8 times 4.742 divided by 0.142, and we end up getting 5.89 times 10 to the 5th newtons. I hope this was helpful. Again, if you have more requests, please send them in and I will do them as soon as I can.